fantastic. So I will speak about the smartphones, iOS LiDAR, software support, and iScanForest showcase. So what is measurable with smart devices is, as I say, diameter, height, bezel area. There is a wonderful application. If you want to know, this is not our product, but I'm just saying, this is from Boku University, so it is Bitterlich, which measures the bezel area. You can, of course, use camera for photogrammetry, construct the clouds, etc. Then, of course, the smartphones or smart devices are equipped with GPS, then you can measure position, polygons. For forestry, you can measure clear cuts and roads and scan if someone passed somewhere, checked something, and so on. But the real devices are, for example, accelerometer and gyroscope. So with these devices, you can measure the most important thing, which is distance, because you can measure distance by angle, okay, by trigonometry. Once you have a distance, you can very precise measure horizontal position, because you can measure the azimuth, and then you can measure height and diameter. So you can make kind of full inventory. So this was a situation 2 years ago, and 2 years ago with March 2020, so a little bit. So we have a LiDAR, as you might know. The LiDAR was equipped with so far only on iOS devices, so iPhones and iPads, but if it is successful, I'm pretty convinced it will also appear in Android. And what we can measure with LiDAR actually is everything. Yes, because we can measure anything you can imagine, as you know, using the LiDAR. Of course, there are some other sensors, then there are some, you can ask me later, there are some applications for lie estimation and so on, which are, but not that common. As for LiDAR, Martin organized a big study some year ago, where he forced us to walk in the forest and measure how everything works, and we compared ZEP, we compared photogrammetry, and we compared iPad, the sensor on the iPhone, and actually the best came out as exactly this iOS LiDAR. What is this iOS LiDAR? Is a small infrared light-based LiDAR, which is only 24 by 24 pixels actually, so it's only very few. But if you are close enough, then the accuracy is very high. I'm speaking about this only to present it as a technology. Okay. Also, the application which I'm showing is not yet on the App Store. We are still developing it, but it's something for the 3DForEcoTech as an idea what can be used. So the main problem, or anything which, when you work with point clouds, the main problem and main drawback is that if you are coming out of the field, you don't know what you have. It might even happen that you don't have a point cloud at all, because it will not simply be calculated. Even using ZEP and these kind of technologies, you scan everything perfect, go home, and there is nothing. Okay, so I'm speaking about these countries, again, like Africa, that you really invest a lot of time, and then the processing times, if you calculate these missed moments, will be much higher than estimation. So what we want to do, or what is able to do, or what this technology is able to do, is actually vectorize the point cloud in the field. So you don't produce point cloud, but you produce vector information. So you produce positions and you produce diameters directly as a numbers. No point cloud. You can have a point cloud, but you immediately have the real measurement. So this is the main, let's say, strong part of this thing. And in that thing, we have to remember that there is not only scanner itself, but also the technology, which is software. In Apple, as I say, also Google is developing it, but Apple is developing one SDK, software development kit, which is called ARKit, and it is not completely published. Okay, so something is published, something not, but you can have the output. So it creates a mesh over the things, and then you can measure diameters, you can measure the positions, and so on. What we can, only for you to remember or be aware, what we can expect in future are these things on the bottom, which is so-called stored experience. So you can save everything in the mobile, come 2 years later and reload it and see how the forest looked 2 years ago. Then shared experience, this is very important, because you can have two iPhones and they know about each other. So for example, you can measure height and one guy can measure diameter and position, and other can measure height, because it is possible to measure height as well, because you can have the distance and the angle, so you can measure height easily. And object recognition, so if you have any specific object like rock, some 3D, something can be automatically recognized, and that's what I speak about this. This is what is existing. Now I will show you, because we are very high-tech, but it's not working, our sharing from the mobile phone, but later during the interval I can show you how does it work. So this is hopefully the video you can see. So if you are walking in the forest or in some area, after some time, I hope you can see there is some mesh created over the trees. And once, it's not, okay, it's fully visible, but once you click, then Ransack algorithm will try to fit the circle, and you can have in that moment you can have the position and the diameter of the tree, or VBH or whatever. Okay, so that is how does it work. Maybe you might be interested how precise it is. So we, in the paper of Martin, the accuracy of diameter was 2 centimeters, but I also want to remind that this can measure the positions, like Julian will present later, the positions of the phone only by itself, so only by the SLAM technology, and we tested it, our students, and the average error without any GPS, so in no GPS environment, actually in 200 meters, you see, or 250 meters is approximately 2-meter error. So it means that if you are working, for example, even in our countries, in national parks where there is no coverage and there are, let's say, southern valleys which are deprived from GNSS at all, then you can still position yourself with a very, very high accuracy. Okay, I'm a little bit, of course, over positive, because sometimes we have the errors of more, but in general the error is 1 meter on 100-meter movement. Diameter errors are described in Martin paper, but also we have to remember that everything works with circle fitting. So if we, of course, use anything else, maybe also the accuracy will be improved. So the app we already saw, and as I say, we can skip this part, and if you want, I can show you this application later. So it basically, as I say, if you start it in a correct or in the fixed position, it will always measure the same. I have to say that we cannot use GPS during the measurement, because again, if you understand how the SDK is working, then the GPS would cause an error, because it will always use Kalman filter to mix everything together. So it's better to not use GPS and only measure the position using the SLAM and photogrammetry. And that's also some conclusions. The 3D data nowadays can be acquired with very high accuracy. Only iPhone, iPad, but I'm not reselling iPhone, so I want to say that I'm sure that in Android it will very soon become available, just in case iPhone has a new green edition, if you are interested. And the horizontal positions can be measured, yes, tree number, basal area, competition, and so on. We have to somehow always think, important thing, that we are adapting something which is not being developed for us. Okay, neither Apple, neither Google are working for foresters, so we have to learn what else they are doing. For example, very important thing is that we are all from generation probably where we are used to have buttons, okay, as an interaction between us and computers. This is being abandoned. So don't expect buttons. There are many swipes. For example, you swipe up, swipe down, left, right. This is the interaction with the mobile phones. This is something important to remember. If you touch it or grab it or do something with it, that future will be for this. It's actually very funny that if I give this application to young students, and I tell them it's using swipe, they immediately are able to work with it without any, naturally, they start to work with it. For me, it's also difficult. And to be honest, of course, I have to say that this is not the only app. So our colleague Tatsumi and his group, they also developed, and this one is already available on App Store, Forest Scanner, and probably many others. And I apologize for all of those I didn't find. And that's all. Thank you for your attention.
Thank you, Peter. Any questions for Peter? Yes, Kim? Oh, no, but then the remote participants won't hear you. Sorry.
Thank you. Have you compared your app with the other app or something like this, or is this something that's ongoing to benchmark? Because it's so accessible and we will generate a lot of data, but how can we compare those data sets with each other?
You mean this one, Forest Scanner?
For example.
Yes. So we are in contact with them, and we have the technology is the same. So for the diameter is the Ransack. It's absolutely the same. So everything else depends on the quality of scanning. And the difference is that we are using interaction. So you have to click on the tree where you want to measure, or on the ground when you want to register some grass. And they are using some object detection automatic. So if you approach something, it will automatically detect it. That's the only difference in the application. Technically, it is the same.
One other question. So if you would scan a tree from a different side, the same tree in your app, do you see a large deviation?
Actually, it's like this. I don't know how much you are aware of this Ransack algorithm. So if the circle is more suitable for different, it will be different. If the tree itself is perfectly circle, it must be again the same. So it doesn't matter which side. But we are also trying to store also the cloud, I mean the section.
There was another question, sorry. Behind. Go ahead.
Chair. So if I understand this application, you've developed it with the idea for remote uses and in developing countries. You mentioned Africa.
No, for whoever, even for us, yes, because we also have this problem that we are working with the clouds, and in the national parks here in Czech Republic, there are some zones which are very, very hardly accessible. And if you go there and come back and then you see that the cloud was not compiled or aligned, then it's a problem. It probably will never be as precise as a real good point cloud, but at least you are coming with some reasonable data.
Yeah, I was just wondering if you've kind of worked with more local stakeholders in developing countries, or the foresters in local foresters, to kind of see how the application actually answers what they need.
In the third world countries, not yet. Most we are now thinking of our, let's say, kind of inventory. How do we do it?
Two fast questions. One, the positioning. For what I understand, you get relative positions, you don't get absolute positions. What is the step to get to absolute positions? Because that's a bit what's required nowadays to work with other remotely sensed data. And then, are there any plans of open sourcing the code? Because that, especially in the context of such cost action, it seems like a very interesting option to, plug in some more AI or some additional features to these type of apps.
Yeah, so the first question is you can use, of course, GPS, but it will confuse the algorithm. Better is to measure GPS separately and then say the center of the plot is something. Or how do we use it? We have the network of geodetic points, which you probably have in Norway as well. And you can position yourself on this geodetic point and go somewhere, and then you have exact polygon line. As for open sourcing, of course, it's nothing extraordinary in the code, so we can open source it. I'm just not sure about the Apple policy, but I'm still expecting that Android will react soon. Google will react soon, and maybe within a year they will also have some phones with with LiDAR. But also, as we are still developing it, actually feel free to suggest what could be inside such application. We can develop it.
Yes, thanks, Peter, for the presentation. And also following the direction of Stefano, what are your next planned steps in development? Because as you said, there is a hard market, a lot of competition in this field, a lot of companies popping up, developing similar solutions. And I see two directions where you can create a unique selling point. One direction would be to include more domain knowledge, because you have all this forestry knowledge and others might not have. And the other thing is what also Stefano pointed out, to include more other data sets also. Like we are not working in a world free of data. We might already have other LiDAR point clouds and so on, or a forest inventory, and how could we combine the real-time capturing with the already existing very rich and valuable databases. So what do you have in mind as next steps of development?
So as the very next step, we try to solve all the bugs which are in the software. But as a general rule, we don't want to do it as some commercial product. Yes, it's for sure it is free. We can even open the source. As I say, there is nothing extraordinary in it. And my main need for such application is for remote sensing calibration plots. So we have a lot of remote sense data, and we need these calibration plots. So the most important thing is to precisely come to some position and measure the individual trees and to link it. So that's kind of overall frame direction.
One last question, please.
Okay, did you try to use this application in cropping systems? For example, cropping avocado trees to check diameters in other systems that are not forests? Because there is a big application for this, very big need. Yes.
I have only avocado of 3 centimeters, which my daughter planted. So the positions will work anytime. That's what I am sure. The diameters are depending on how close you can get to the thing. So you can count like 5 centimeter trunk. You must get half meter distant. So if you can get to this distance, then you can measure it with good accuracy, and then it can be used for such purpose.
Fantastic. When does it come to underweight?
I hope soon, next week. This is what I'm saying, 1 year already.
Okay, thank you, Peter.
Thank you.